Scrap Mechanic RGB Test Vlog 1. I've been working on this since 2024 with some breaks in it, and this is the attempt to make a full 16x16 RGB display to not only maybe someday play games on it, but also to show videos and GIFs and such on. This is a simple set. This is the RAM of the 16x2 RGB display, with each row, like this is a simple cluster row, is one line of the 1x16. So we have two of those RAM systems to work independently to fuel this monstrosity. This is the on and off button and the clear button, and this is the reader. The reader is quite simple. We take cardboard and make our little paper, I guess, where every information is on, like a punch card, for example, from the old days. Then we give the color information. This is on off, this is lighter, darker, the blue value, the green value, the red value. Then we simply color 3 blocks for 1 bit. For example, we want to have a color shift. I'll just paint this whole row white because every light is going to be on. And we start with red. Then with red green, for example. Then only green, blue green, then only blue. Then purple, and those are the different colors I'm going to choose. And now I'm going to lighten them up with the white value. So I'm just doing the exact same. And this should be actually enough. And then we color the address in. This is address 0. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, we only need actually 10. I did screw up for a second, I'm sorry. Where did I do my coloring wrong? I did it here. This, and then we do a little bit of this. This is the full card. I'm going to put it now in the machine, and the machine automatically reads it and then clears the punch card. You could save that actually. I think I even saved some in here, some punch cards. I don't know. I believe I did, but I'm not fine. Oh, here. This is the same example. I can put that later into. Well, here's the card. The machine is turned on, and you can actually see it being turned on because all the lights turn off. I start the machine, and red. Sometimes it gets stuck, but it should work its way through. See? There is probably a way faster method, and I'm trying to find that, but that takes some time. And I'm sorry if you hear my chair. I'm deeply sorry. this should slowly work through it. And here's the progress the machine goes through. It gets red and instantly deleted. I thought for safety maybe adding another row of deletion, but this seems to be enough for now. And it's slowly going to read through every one of those. And as you see, we have dark red. Wait, we have dark red, lighter reds, and it's a whole RGB screen. And the farther you're away, the more you can see actually the color. So it is working as I want to. Then we could take a look at the RAM. This or those lines up here are data lines. They just transmit the raw data of that. So you will see the color that is right now chosen. Then there is this little part here. This is the actual thing that turns this data string into the 16 or rather 32-bit address. 5-bit address, but 32 different sections. I still have to fix one bug, as you can see. Sometimes it depends. If you have 4 or 3 lines, if you have 4 lines of information, it sometimes starts to flicker like this. But there is already a fix for this. And it read through the whole card. Like if it's past this, it's fully read. We can dig this out for a second and try this punch card, for example. Turn it off, turn off the monitor, it's reset, and this is the wiring it took, by the way. Lovely. And here are the different colors. We have red, blue, green, the white one, and we have the logi gate that tells it to turn on. And yeah, this is a simple demonstration right now of what this machine will be able to do if I finished it, of course. It takes precious time, but I think I will get there. Let's try this punch card. This is actually every second color. Interesting. I do not remember that card because I did that a few ages ago. I'm just going to let that walk through. I do remember now what this is. It turns this one off and then turns this one on, turns this one off, turns this one on. Like the line goes further and further and further. It turned it off, as you could see. I definitely, as I said, I have to find a faster way to do this, because it is quite frankly really slow. But it works. It is a fully self-loading system, and it saves it. And there's the one bug I mean, where the light sometimes flickers. And I did one error in the coding. I forgot to turn this one off, but I think you get the idea of it. And as I said, the colors are getting better the further you're away. So you can see now this should be more yellow, cyan, blue. And yeah, I do have a static image of it, which I can I do have a static image of it, which I can show. Now we are in the test world. I did the giant RGB display. You can see it in the background. Here is the first test of my 1x16 display. It's rather short because I am only using 3 lights and the on and off button. So the upgrade to this was dramatic. You can see even the little data cells are way smaller. And one big advantage of this one, we have this system. This one is for the address, however this one is deletion, and this one is the actual colors, and you will see. So I'm turning the machine on. This one is manual input. I can manually put an address in and set the colors, but I'm not doing that. I'm just turning the machine on, and it's just magical. And this is the first iteration. And yes, I did leave that spot on purpose empty. And as you can see, red, blue, cyan, green, pink, everything. Just everything you need. We do have now the deletion button. I've added that. Simply, you turn this on, turn the deletion belt on, and you'll see it's getting all deleted in the RAM. Quite frankly, I can hard code a program, so I do not need this. This is kind of hard coded, but as a chip form. And I planned on using the system for this small thing. This is a small messenger, I guess you could say. This is the side I'm drawing on. This is sending and receiving. Let me send to the one side a question mark. And yes, this is the cable that sends the information. Now let me turn on both displays. I want to receive the image. Oh, a question mark. Let me send a frown. And it gets sent over there, as you can see, over the data bus. And from that I started to, this was just a test, but then I got curious how much I could improve my systems, displays and such. So my first idea was to build something like this and just use it on the other side. Oh, excuse me. This is a simple color display that takes black input and puts it digitally, so you could, for example, write your friend this should be hi, how are you? You could literally just write the individual letters, but this system is flawed because it takes way too long and you cannot save anything. So I've planned on putting a save feature in, and then I thought to myself, okay, what can I do? And I built that thing over there. And there's a little thing I'm going to show in a bit. But first I'm going to show the RGB display in its full potential. Like this one. This is, as I said, hard-coded, but look at the colors, man. This is vanilla script mechanic. I do have mods installed. I don't believe yeah, see? But not on this world or not on the other one either. Because in the mods there are actually data chips that can store values, but I'm doing everything in vanilla. But look at this beauty. This is hard coded, as I said, but like you can see the colors and it's really beautiful. And the further you get away, at some point there's diminishing return, but from this view on, like over here, this looks sick. And I do believe this is a 16x16, yeah, this is a 16x16 display. I wanted to do one bigger, but no, it's actually 32x32. Oh man, I didn't realize. But this is the potential everything could have. And I thought of doing a different system, and I want to have some ideas. Maybe some of you do scrap mechanical logic, but to turn the individual light strand, because this is all what's underneath. This is one light. To put like a RAM behind it, so I can individually just address the RAM and do not have to build such large constructions, because it quite frankly gets out of hand very fast. Now we are at my testing facility, where I tested different systems. First of all, this is the actual RAM I'm using now. It's a bit bigger than the RAM I'm using over there, but it has its advantages. This system is the same I would apply when I am doing the RAM on the actual lights. You see, nothing happened. I just pushed the button and you saw this. But now if I'm like, I want to color those two, this is the refresh rate of it. It's slow, even if it's like a big screen, it's really slow. So I'm trying to invent new technology to do faster sub-tick systems. But for now this works. This one is something in particular. This is a system I am trying to develop, or I tried to develop. This is a line switch. So now it's on receiving and now it's on sending. But it did not quite work out as I want. This is actually like a loading screen. It's working, it's working, it's working, going through all options, and now it's finished. If you want to see it from the back, it goes through every possible state right now, and it's finished. This, I do not know if I'm implementing that, but would be quite nice. This is the same system actually as over here, but in large. And as you can see, it works. It actually works. But oh, why is this not connected? But this was such a pain to integrate. And now we come to one of my fastest designs yet to refresh a monitor. And as you can see, it goes through every possible position, but sometimes it lags, so I don't know how to fix that, because I'm getting to the territory that the tick system isn't following anymore. But for now, it's actually good. And as you can see, I can stop it and it rests at the position where it was. So I could actually increment it by one by hand if I want to see like individual bugs. And yeah, this is the whole thing I've been working on since, I don't know, 2 years kinda. it's there haven't been many breaks, so that's the explanation. I have a whole sketchbook full of things, and as I find this, I can explain this. This is the system I've been using for the 16x2 setup actually. This switches which side it's on, and I can go through everything. So bop, wait, bop, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16. Switches to the other side, and I can start from 17, 18, 19 and so on. So this is kind of the whole scheme that I'm working on right now. It is quite a lot, but I hope I'm getting through with this. And actually here is the system I've tried for the reader back there. And I can show one interesting thing, because I built this out of scratch with no prior idea. The 4-bit decoder that I have over there. This is the same. This is the same, but it's quite ugly. I could replace it, but there's no charm in changing things when this is the original. And yeah, that concludes the vlog 1 about my RGB display and script mechanic. I hope you enjoy it. Thank you. Hello, so I have to butt in for a second. I forgot to ask something and say something. First of all, I'm grateful that you watched the show so far and are at the end. Secondly, if you enjoyed the video, just like it. Come on, man. I'm just doing this for fun and bringing something back to the community of script mechanic. So this is all stream I'm having. If you want to know how the technology works in depth, I gladly do a video about it, titling like in-depth technology review RGB display block 1. Everything will be in blocks, so expect every title to be something about blocks. If you want to see more and have ideas, tell me. I will gladly try ideas. If you want to get in contact with me, I'll gladly let you give me ideas over Discord. So that will be it. Thank you and have a great day. Bye.